So good day everyone, I am Jamie Arnatabio, and for today's lesson, we will discuss about random sampling, Module 3, Lesson 1. So for our introduction, some researchers aim to study, describe, and infer patterns of behavior, properties, and characteristics about a population. Sometimes they intend to study in a very large scale, and because of the fact that we cannot study a very large population due to feasibility, impracticality, and inconvenience, that is why we must select a representative sample from the population. In this lesson, sampling techniques that will help researchers select samples that would represent true inferences about the population where these samples came from. So we have our objectives. Our first objective is to familiarize the importance of population and sampling. Our second objective is to identify the 4 types of sampling methods. Our third objective is to give on situation in each type of sampling method. Our fourth objective is to know the Sloven's formula, and our fifth objective is to find the interval. So as I have said earlier, we should first familiarize with the population and sampling. So the population is the group you want to generalize. It consists of all the members of the group you are interested in. Sample is the subset from the population you want to examine. A population commonly contains too many individuals to study conveniently and practically. So an investigation is often restricted to 1 or more samples drawn from it. A well-chosen sample will contain most of the information about a particular population parameter, but the relation between the sample of the population must be such as to allow true inferences to be made about a population from the sample or from that sample. In short, population is a group while sample is the subset from the population, or the sample is a set that you choose or you pick from the population. So another one is sampling. Sampling is a process used in a statistical analysis in which a predetermined number of observations are taken from a larger population. Or in short, sampling is a process in a statistical analysis to predetermine the number of observations from a larger population. There are various sampling methods that allow all the units in the population to have an equal chance of being selected. So for us to familiarize with the type of sampling methods, let's proceed. So our first type of sampling method is simple random sampling. Simple random sampling, each element of the population has an equal chance of being selected. There are no rules that dictate where and how you will start the selection process, as long as you do not intentionally look for specific number. So you can consider a scenario if, as a simple random sampling, if you do not or you unintentionally look or pick for that specific number. In this method, the samples can be selected through our first sample is the lottery method. Lottery method. Every member is assigned a unique number. These numbers are put in a jar and thoroughly mixed. After that, the researcher picks some numbers without looking at it, and those people are included in the study. So, the best example for lottery method is the lotto. So, if you are guys familiar with the lotto or how the lotto works, there is a glass box, and inside the glass box there are full of balls with numbers, and then it will mix by the pressure of air below the glass box, and then later on that glass box itself will pick a ball with a number. So unintentionally because it mixed. So it is a type of lottery method. So for another example of lottery method, if you are guys going to play a game, and then to be fair, you guys pick a jar or fish bowl, and then you put your names on it, and then someone will mix it, and then someone will pick inside that jar unintentionally without looking at it. So it is also an example of lottery method. So our next sample or our second sample is use of table of random numbers. This table consists of a series of digits 0 to 9 that are generated randomly. The numbers are arranged in rows and columns and can be read in any directions in any direction. All digits are equally probable. So the example or the another sample for this method is if you are guys familiar with Sudoku, it is also have a arranged rows and columns that can be read in any direction, and it have a series of digits 0 to 9 that can be used in digits 0 to 9. So it is also an example of table of random numbers. Okay, for us to determine the designed number of samples needed a given certain number of population, there are also some formula, but this formula is one of them, the Slovin's formula. So for us to know how the Slovin's formula works, Slovin formula is equals to n is equals to n divided or over all over n e squared, where where small letter n represents sample size, and then e represents for margin of error, and then capital letter N represents for population size. We have an example here where we find or we're finding the n or the small letter n or the sample size. And then our given here is E is equals to 0.05, and then capital N is equals to 1,000. So our first step is to substitute the given in the formula. So we have n is equals to 1,000 divided by 1,000 times 0.05 squared. And then we will first solve the exponent. So 0.05 times 0.05, because it is squared, is equals to 0.0025 or 25. Therefore, we have n is equals to 1,000 divided by 1,000 times 0.025. And then next, we will solve the parentheses. And then 1,000 times 0.025 is equals to 2.5. Therefore, we have n is equals to 1,000 divided by 2.5. And then we will just divide this 1,000 divided by 2.5. Then we have n is equals to 400. Therefore, we find our sample size, and then our sample size is 400. That is how the Slovin's formula works. Okay, I have a sample scenario for simple random sampling. Our example here is the names of the employees were being selected using lottery method. So I already sampled this earlier. This can be considered as simple random sampling because it used lottery method. So we are done for the simple random sampling, our first sampling method. So let's proceed for the second sampling method. Our second sampling method is the systematic random sampling. Systematic random sampling, this can be done by listing all the elements in the population and selecting every kth element in your population list. This is equally precise as the simple random sampling. It is often used on long population lists. So the kth element, it is an ordinal. So for us to consider a scenario as a systematic random sampling, it should have the ordinals or the kth element. Okay, so for us to find the interval to determine the kth or the ordinal, we have also a formula. So the formula is k is equals to n divided by n. So the k represent for the interval, and then the small letter n represents for sample size, and the capital letter N represents for population size. So how we find the interval? So first we should substitute again the given on the formula. So k is equals to 2,000 divided by 500. And then we will just divide it. 2,000 divided by 500 is equals to 4. So we have k is equals to 4 or fourth. We will use the ordinal here. So the ordinal here is the fourth. Again, I have also another sample scenario for the systematic random sampling. So Lucas can give a survey to every fifth customer that comes into the movie theater. So this sample scenario can be considered as systematic random sampling because it have an ordinal. This is, or the fifth is the ordinal here. So this can be considered as systematic random sampling. Okay, we're done with the second sampling method. So let's proceed for the third sampling method. Our third sampling method is the stratified random sampling. The stratified random sampling, this can be done by first dividing the elements in the population into strata, and then samples are randomly selected from each stratum, ensuring that each selected element is proportionately represented in the total population. So here is another sample scenario for stratified random sampling. Some researchers are conducting a research about vaccinations. They decided to divide the people by age of 12 to 18 years old and 18 to 50 years old. Then they selected from each group by age. So this sample scenario can be considered as a stratified random sampling because they first decided to divide the age. So it's 12 to 18 years old, then 18 to 50 years old. 18 to 15 years old, and then they selected from each group by age. So they divide first. So this can be considered as a stratified random sampling. So we're done for the third sampling method. So let's proceed for the fourth. This is the last but not the least sampling method. So our fourth sampling method is the clustered sampling. Clustered sampling, a multi-stage sampling method adopted when it is either impossible or impractical to compile an exhaustive list of elements found in the target population. The whole population is subdivided into clusters or groups, and random samples are then collected from each group. Again, the whole population is subdivided into clusters or groups, and random samples are then collected from each group. So a scenario can be considered as clustered sampling if there is a group and then random samples are collected from that group or for each group. Again, I have another sample scenario for clustered sampling. So, an NGO wants to create a sample of girls across 5 neighboring towns to provide education. So, this sample scenario can be considered as clustered sampling because they first pick 5 girls. I mean, they subdivided a girls from each 5 neighboring towns. So, this can be considered as clustered sampling. So I hope you learned something from me for today, and that's all. Thank you.